Whoa! Whoa! That's so odd! Oh my god!
Although body ownership may feel like a stable concept to us, the rubber hand illusion shows us that our physical sense of self is a lot more malleable than we may realize. The illusion works as follows. A person's real hand is hidden from view and visually replaced with a fake rubber hand. By brushing both the real and the fake hand simultaneously, the brain merges together the feeling of our own hand being touched and the visual input of the fake hand being touched. The more activation of the brain areas that integrate the visual and the tactile information, the stronger the feeling that the rubber hand is part of our own body.
Like, I actually feel like that's my actual hand, and my hand's just really pink for some reason. It's swollen.
When this new hand is threatened, we respond to it in the same way we would respond if it was truly part of our own body.
Yeah, that gave me a fright.
Whoa! Whoa! That's so odd! Oh my god! Nah, I don't like that.
On a neurological level, a threat to the rubber hand has been shown to induce a similar level of activity in the brain areas associated with anxiety and interoceptive awareness as when the person's real hand is threatened.
The feeling of floating up out of your body and looking down at yourself is known as an out-of-body experience and has been reported by many people around the world. The Federal Institute of Technology in Lausanne is conducting experiments to find out whether the out-of-body experience is an illusion or has some other explanation. For example, in this test, the woman sitting at the table can only see a plastic hand through the glass top. She's asked to put her real hand in the same position as the fake hand. The neuroscientist then proceeds to simultaneously stimulate both hands, her hand and the plastic one, with two small brushes. The woman feels one brush on her hand, but sees only the other brush moving on the plastic hand.
Und genießen. Und genießen, okay.
Now I'm beginning to feel the impulse to move my middle finger, although it's the plastic one which isn't straight.
The part of our brain which decides whether something is an illusion or not is the angular gyrus, a spot behind our right ear, strategically placed at the crossroads of different sensory areas, specialized for processing touch, hearing and vision.
When all the different sensory areas which make us aware of our body and of its position in space aren't communicating properly for whatever reason, it's possible that the brain, puzzled by this, starts to process data about our body in a totally new way. Hence the feeling of seeing yourself from a different perspective, out of your own body.
In this other experiment, the scientist puts a camera high on top of the woman's head and blindfolds her. Inside her blindfold, she has the camera view of herself and her surroundings. A recreation of the out-of-body sensation.
This is so weird.
Ganz komisch.
Catching a ball becomes a real challenge for her.
Kannst du mal versuchen zu fangen? Ja, das wird schwierig. Keine Chance.
And she doesn't trust herself going up the stairs.
Vorsichtig. Wow. Da irgendwo ist das Geländer.
You'll catch me if I fall?
Sie heben mich, falls ich umgehe.
Hatte sie jetzt gedacht, dass es weiterhin... You feel the steps aren't where they actually are, right?
Ja. Oh.
Gut, dann mal umdrehen.
It's a bit like learning how to walk.
Es ist wie alles neu lernen.
Genau, ja. Wow. Jetzt fühle ich mich schon ein bisschen sicherer. Ah, das ist fest.
This was the last step? No way.
Doch.
What you need are a box about the size of a 12 wine bottle box, scissors or a box cutter, a table and a couple chairs, a towel or a jacket, two pointy objects like pencils, chopsticks, or paintbrushes, and 3 people per group. Now I'll show you a video of the box after I've cut the holes in it. Here's one side with a small hole big enough for an arm to easily fit through. And the other side, which is the whole side cut out. Now let's see how it works.
Okay, so I've got the box like this, and I've got the circle side close to one side, right? The small hole is close to one side. I'm going to put that here. If you come around here, you can see where that is. And I'll put my arm like this. And then I need like a blanket or something. You can just use anything, like a jacket. You put your hand on under the jacket, and then if you'd come over here and come around behind me, and you put your hand underneath my elbow and underneath here, and you lay it down so I can see it here, right here. Yeah. Now you're trying not to touch me, because I don't want any information from contact with this arm, and I want him to position it until it looks kind of like it could be roughly where my arm could be. Okay? So maybe come over here and take a look. And if you look here, now you'll see I've got my hand here and his hand here. I'm trying not to touch him under here, but I'm covering this so that it kind of looks like that kind of could be my hand.
Recording?
So, now, one more thing. John has a shirt on.
I can take my sweater off.
You should pull it all. You take the sweater off. Because you want as many cues, you want as many visual cues as you can to be the same. All visual and tactile cues should be the same. Okay, so your hand's coming in here. You're trying as little touches here as possible. So try not to touch them, if you can. Then we'll put this over here so that so you get a little confused visually. Now John's going to look not at his hand, but at this hand, right? And I'm just going to spread this a little bit so it's roughly the same position. Now if you come over here and videotape in here, yes?
Does it help to put this between the arms? Or is that
yeah, that's a good idea. That's a good idea. Okay, now what I'm going to do is, these actually should be as similar as possible, so this is not an ideal situation. But I'm going to come here and I'm going to touch both hands in the same spot exactly at the same time. So here I come, and I'm going to tell John to keep looking not at his hand but at this hand. Now I'm going to tell John also, he's already smiling, but what he's looking for, he's trying to experience what it's like and what his brain is doing as I do this. And to see if he can notice a certain point where the brain starts to think this is his hand. And maybe even switch, like think it's his hand and then suddenly think it's not his hand and then go back again. And I'm trying different parts of the hand, but what I'm doing, the contact has to be at the same place at exactly the same time.
If I want to, I can make this really seem like
good. So
hand.
You should want to.
You want me to.
Yeah. You want to sort of release your skepticism. It's not that you want to have a vague sensation. You want to have a very strong sensation ultimately.
So I direct through this hand.
Yeah, whatever it takes.
Yeah.
You're trying to give yourself a very clear sensation that this is your hand. So the wanting is just a means there. I don't want you to have a vague, like, well, kind of, sort of. I want you to really feel like, whoa, this is getting weird. Yeah?
Yeah, that's my hand.
Illusion that has been published in 1998 by two Americans, Botvinnik and Cohen, two American neuroscientists, is the rubber hand illusion. The rubber hand illusion consists in placing, let's say, one's left arm out of sight, out of vision, and placing in front of the eyes of the subject a hand in plastic, a rubber hand. And then the experimenter will stroke, let's say, the left the index finger of my left hand, and at the same time the left index finger of the rubber hand. And if he does this synchronously for a minute, up to 2 minutes, certain subjects, 2/3 of all subjects, will start experiencing this hand for some moments as if it were belonging to their body. So this is one way, and this is normally investigated by questionnaires. So the subject will be asked a certain number of questions to respond to. And then there is a second measure, which is, in my opinion, even more interesting, because if you then, after these 2 minutes of stroking, will close the eyes of the subject and ask them, well, now point to where your hand would really be, they do not point with eyes closed to the real arm, they will point towards the rubber arm.
I really felt that my hand was transposed and into that false hand that was presented in front of me. The feeling was really an awkward feeling, a very strange feeling of having a false hand belonging to me. We visually see that the hand is false, but we can't separate that from the fact that we actually feel our hand in that place.
By simultaneously stimulating fake rubber hand and the real hand, something that is felt and something that is seen on a hand is integrated. Under normal conditions, when I see something close to a hand and I feel touched at the same position, this is always on my hand, at least I guess in 99% of all cases. So by disintegrating these two types of information, the experimental psychologist interferes with those brain mechanisms that we have through phylogeny, but also through our own development, learned that our brain has learned to fuse together.
Ellie!